So service mesh to service mesh. Imagine an uncontrolled roadway. Imagine there's no limits, there's no speed limits, there's no traffic lights, there's no signs. In a small town, this works out really well. In time, maybe this doesn't work out so well. So we've got that one county traffic cop who's standing at the edge of town with his radar gun, and he's going, you know, I'm going to improve this scenario. I'm going to stand at the edge of town, and anyone coming in who's not obeying the rules, I'm going to grab them, and I'm going to make sure that they obey the rules. In time, maybe we'll get more traffic cops, and we'll kind of spread them out throughout the town. And unfortunately, the net result is that we're enforcing conformity, but we're still not optimizing for the goal that we want to get to, which is to get from where I am to where I need to be as fast as we can possibly go, as efficiently as we can possibly go. And that's a great analogy for how service mesh kind of fits in this scenario. We can start with a cluster with services where anything can kind of talk to anything. And we can get to a scenario where we have very specific traffic patterns, and we can adapt to changes in our traffic patterns to ensure that we have a lot smoother roadway. Let's dig into service mesh. Here's the part where I tell you I'm definitely going to post my slides on my site tonight. You're going to hit my site tonight, tomorrow. You're going to be pushing refresh next week, next month. In about 3 months, you're going to get tired of checking. You're going to email me. And in about 6 months, I'll promptly reply and say, no, I'm definitely going to post these slides on my site tonight. Which is why you can go to my site right now, robrich.org. And as you go to robrich.org, you can scroll down to service mesh to service mesh. And here is the slides that we're going to look at right now. They are online right now. While you're there, you can see some of the things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. AZGiveCamp is wonderful. AZGiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start Friday after work. We build software for them. We deliver that software Sunday afternoon. Sleep is optional, caffeine provided. Come join us in Phoenix at our next AZ Give Camp, or if you'd like a Give Camp in your area, come reach out and let's see if we can plant a Give Camp in your town. Some of the other things that I've done, I worked on the Gulp team in version 2 and version 3 as a core contributor. I've written a book, SQL Source Control Basics. Mine is chapter 8. And I do training through getgrit.com. If you like what you see today and you want this in your organization, we can definitely make that happen. Come see me and we can do Kubernetes and Istio and Docker and all kinds of other interesting things in your organization. One of my claims to fame is I posted a comment on the .NET Rocks podcast episode. They read my comment on the air. They sent me a mug. Woohoo! So that is my claim to fame. So with me, except for not with me, is Kavya Perlman, my good friend. She helped me build this presentation, and she is an amazing person, a cyber guardian for WallArm. She originally worked for Facebook during the presidential election and got to see all of the wonderful and wacky things involved in security and all of the abuses firsthand, which was amazing. She then moved on to Second Life, where she was in charge of the largest online community, and that was amazing. She now runs the XRSI Foundation, doing security around virtual reality and augmented reality, and that is really amazing. So I'm grateful for her help in putting this presentation together. So what are we going to do? We're going to look at kind of what is a service mesh, kind of the history of how we got from to where we are. We'll look at both Istio and Linkerd, and then we'll demo each of those, which will be really fun. And we'll look at kind of service mesh best practices, when you might choose to use service mesh, and when this might be overkill, and when you might want to avoid it. So let's dive in. A service mesh. A service mesh manages the network traffic between services in a graceful and scalable way. Service mesh is the answer to how do I observe, control, or secure communication between microservices. That's kind of a decently crisp definition, and let's dig into a whole lot more of what that means. But at the outset, it's a way of managing communication between services. That is the service mesh. As compared to a mesh of services where I have all of my microservices communicating, a service mesh is the thing that controls the services. It does not replace the services. I still have my mesh of services. I just choose to control them with a service mesh. Arguably, the title service mesh is really awful for exactly that reason. It does not replace my services. It controls my services. So we want to talk about kind of the main principles of service mesh. Observe, control, and secure. And that's really the foundation of what we're going to do with a service mesh. We're going to observe traffic between containers. We're going to control that traffic, validating against policy rules and traffic rules. And we're going to secure that. We can use mutual TLS to ensure that communication between containers is secure. Observe, control, and secure. We'll come back to that about a dozen times. So how did we get here? Well, we started out with a monolithic application here on the left. And the monolithic application, we built all of the pieces into one deployable component. And we chose to deploy it as a monolith because deployment is hard. And so if we didn't have to do that very often, we could just, for example, deploy our monolith once every 6 months or once a year. Then we didn't have to go through that pain as much. Over time, we moved to virtual machines and eventually to containers where deployment was no longer a barrier. Because deployment is no longer a barrier, we could do it really frequently, like, say, 20 times a day. Now that we can deploy really easily, let's start splitting our applications into smaller, simpler components. So we end up with, for example, these 3 microservices. The user interface will route into the microservices. Each microservice then will route into its data store. And then we're able to kind of architect our application from these loosely coupled components that do really interesting things. So now we have microservices, but now we end up with a mechanism where maybe communication between the microservices is a little weird. So first, I'll talk about north-south and east-west, defining these terms. In this diagram, we talked about how the user interface goes down into the services go down into the... So north-south generally refers to into or out of the cluster, where east-west traffic talks about communication between components. So when we talk about north-south, that's into the cluster or out of the cluster. East-west is between components inside the cluster. North-south and east-west. Which is really funny because we have these north-south diagrams, and then we have diagrams where traffic moves horizontally in north-south traffic, and it's like, okay, are we mixing metaphors by not doing the north-south correctly? That's kind of interesting. So let's add an API gateway. Here was our first step towards controlling the traffic. Much like that traffic cop at the edge of town with his one radar gun, an API gateway is a great boundary around your cluster. Content can't get into the cluster until it goes past the API gateway, and the API gateway says it's OK. But once inside the cluster, we have all kinds of strange stuff where the containers are talking to each other and a microservice is talking to another microservice's data store. We don't have that same symmetry where a microservice owns its own data store because that API gateway will only guard the boundary to our cluster. API gateways are great for guarding the boundary of our cluster, but that's all. They can also do some interesting things about payment and tracking usage and things like that. So it's not just about security. But primarily in the security space, it's just about validating the boundary of our cluster. Any questions so far? So we've got API gateways. And now we want to add a service mesh. Well, what is a service mesh? At its most foundational level, a service mesh will typically use a proxy to communicate between services. So for example, here's this service on the left, this service A. And service A would like to communicate with service B. Now service A typically would just open a socket to service B and communicate. In the concept of a service mesh, it does not. Deployed with each service is this Sidecar Proxy. Now the Sidecar Proxy will kind of do the routing for the proxy. It's, a proxy. So service A communicates with the proxy running inside of its same pod. So it communicates with the proxy inside this network boundary. The proxy will then reach out to the service mesh control plane and say, hey, am I allowed to talk to service B? The control plane can reply and say, yes, you are allowed to talk to service B, and here's the address to service B. It will create a mutual TLS connection off to service B, but it doesn't communicate directly with service B. Rather, it communicates with service B's proxy as well. Now this is running inside the same pod as service B's container. So then the proxy reaches out to the control plane and says, hey, is service A allowed to connect to me? Oh, yes, it is. OK. And so then it routes the traffic off to service B. The reply comes back. It goes through the proxy. It goes through the other proxy. And it goes back to service A. Now, we have some interesting concepts here that are really, really cool. There's mutual TLS between both of these services, but the source code of the services didn't need to change to empower that. That's really powerful. By putting a proxy into each service, we can empower a whole lot of functionality that we didn't have before. Let's dig into some of that functionality. Observe, control, and secure. At its most basic level, we do that, observe, control, and secure. We can observe the traffic. As service A communicates with service B, we can notice that that happened. We can grab logs. We can start to talk about service health and metrics. Secure, we have that mutual TLS between the two services. Outside of a pod security boundary, there is no unsecure communication at all. And in control, we can start creating access policies to say, service A can talk to service B, but service Z can't talk to service B. Taking that to the next level, we can do some interesting things where we can talk about additional functionality. Since we're watching all of the traffic in our cluster, we can do things like track service health. Hey, I noticed that service A was reaching out to service B, but service B gave it a 500. Maybe service B is having trouble. We can grab logs off of all the services. Here's the uptime associated with service B. Here's how often it usually replies. Here's the health checks associated with that. We can kind of get a feel for how these services typically behave. And then what's really cool, because we're watching all of the traffic in our cluster, we can map out how the cluster communicates. Now, this isn't what the developer thought would happen between the microservices. This is the actual traffic flowing between the microservices. Now, what's interesting is we might be able to compare this with what the developer thought would happen and say, I think you might have missed something. Are you really reaching out to the config service, or are you using the hard-coded value you used in debug? That's kind of interesting things to know. Taking a step further, we can look at other things. Because we're routing all of the traffic, we can start to make intelligent rules around this. Maybe we would like to do an A/B test, where we can send a portion of the traffic to version 1 and another portion of the traffic to version 2, and kind of see how those two are behaving. See which one has more customer engagement, which service is able to perform better, or identify the service that is more tuned to the task at hand, and then start routing all of the traffic towards that successful piece. Or perhaps we want to have a beta channel to give new users access to the code faster, or a canary channel where we can validate that the system behaves as we expect. And then what's really cool, circuit breakers. One of the things that we are really good at doing is retrying. And built into a service mesh, we can do automatic retries. But if we retry, if service B is, trying to crank through a big piece of workload, and ultimately it's not able to make it through, the first thing everybody else is going to do is retry it. So as service B starts limping along and coming back up, we're just going to DDoS it again and kill it again. Instead, what we can do in the circuit breaker is we can notice that that service is not behaving very well, and we can fail the request at the service mesh. Traffic will never get to this failing service for a period of time. Now, unlike traditional circuit breakers, you don't have to go walk outside and flip the switch anymore. Instead, we can wait a little bit. Hey, let's try it in a few seconds or in a few minutes and see if the service is behaving better. Once the service is healthy again, we'll close the circuit breaker, and now all of the content can flow as it normally did. Circuit breakers are a really powerful way to heal services dynamically without having to do any manual intervention of the services. Any questions so far? Yep. Good question. How much overhead is that? Ask me in about 10 slides, because we'll talk exactly about the overhead. Good call. Yep.
So in Kubernetes, we have the concept of a service. Is it analogous to these proxies, or are they independent?
Good call. So how does Kubernetes service kind of sync with a service proxies service? To do that, let's dig into Istio and Linkerd and talk exactly about that. Oh, and I realized I missed one thing on the way. Here's a dashboard that kind of gives us both service health and network topology, and this is possible because we're routing all of the traffic between things. So we want to look at Istio and Linkerd. Oh, so one of the wonderful things about a service mesh, if a microservice is to own its own data store, it's really easy to forget and actually call the other guy's data store. With a service mesh, we can isolate a database so that only that service can talk to that database and avoid this kind of cross-join of traffic. So let's talk about Linkerd and Istio. Now, we could get into a bake-off of who has more features or who is faster, and that's interesting, but less relevant because, of course, everybody's going to catch up with the latest feature, and so kind of comparing features is less of a win here. Instead, I'd like to start with a methodology of how things work. Linkerd really focuses on writing their own components, running their own stack, which is really cool. They've contributed a lot to both the Go and Rust communities. But they really want to build everything in-house. Their goal is to have a very simple install experience and a very fundamental set of features that does really interesting things. The downside is if you want more, you need to pull in external plugins to facilitate Linkerd's accomplishing those tasks. It has that same mechanism where it has a control plane, it has a proxy sidecar, a sidecar proxy within each container, and that's how it's able to route the traffic. By comparison, Istio has all of the things included out of the box by default. You can choose to turn things on and off, and we definitely do, but all of the things are there. Istio focuses on including community packages, the best of the industry, and so you'll see a lot more brand names as you install Istio as compared to Linkerd. Ultimately, Istio does that exact same thing, where they have that control plane, they have a sidecar proxy with each container, and it will route traffic between the services or into or out of the cluster through these sidecar proxies. Both of them you will use custom resource definitions, CRDs, to create their content. Istio now has an operator, which is really interesting. And as you install Linkerd, you can see all of the CRDs. It's really fun to watch them go past. You asked about how do these compare. Here's a definition of a virtual service. Now this in Istio would replace a regular service and starts talking about how to route traffic between things. Now I'll create in Istio destinations, service points, and I'll create this service that will route traffic between those endpoints. So, demoing service mesh. This is really cool. I'm going to have so much fun with this. I have here two clusters. One is an Istio demo cluster, one is a Linkerd demo cluster. And so we can kind of poke at them without interfering with each other. Let me switch off to the Linkerd cluster. Now Linkerd is known for being really easy to install, really easy to set up. I've already downloaded the Linkerd executable and put it in my path. And so from here, I'm just going to start installing Linkerd. I went off to the Linkerd Getting Started page, and it walks us through the process of doing it in a really, really elegant way. That Linkerd Getting Started doc is gorgeous. So I'm going to start off by saying Linkerd check -pre, well, --pre, and it'll kind of take a look at my cluster and say, how are you doing? Do you have all the pieces in place that I need to use to be able to accomplish this task? And ultimately, yep, it says my cluster's good to go. Awesome. Next step, let's go install Linkerd. I love this in the demo last hour. Linkerd install. Here's all the CRDs that we're about to put into Kubernetes. Here's all the pieces of Linkerd that get us started. And so Linkerd install is really cool at getting a feel for that. Once the cluster administrator says that's OK, then I'm going to, Linkerd install, pipe it to kubectl apply -f-, and now we've got all of our pieces flowing into our cluster. Now that we've got all the pieces in place, kubectl get namespaces, we see we have this additional Linkerd namespace, which is perfect. Kubectl get pods inside the namespace Linkerd, and we'll see those starting to spin up. I love this tool that comes with Linkerd. I can say Linkerd check. Last time I did the --pre, which just took a look at the cluster but didn't examine any of Linkerd's content. But this one will actually go through and look at all of the Linkerd content within my cluster and tell me if it's running. I got all green checks, so I know that Linkerd is working just fine. That is great. Kubectl get all --namespace Linkerd. And I've got all of the content ready to go. All these services are running as cluster IP, which is perfect, as I expect. That means they're not publicly exposed. So I will run Linkerd dashboard, and that will proxy me into the cluster and pop up Linkerd's dashboard. I'm going to switch off to the Linkerd namespace and take a look at deployments. And we see that already all of the content is being watched. Linkerd actually watches itself, putting proxies, sidecars in front of its own content, which I just think is really elegant. Well done. For each of these, I can pull in the Grafana dashboard just by clicking on the Grafana logo. And here is the metrics associated with the content for that service inside Linkerd. Now this Grafana dashboard was pre-installed, but I could definitely take the Linkerd Prometheus sync and push that off into a more durable Linkerd Prometheus store and start to create more dashboards around that. So Linkerd will definitely dump that content straight into Prometheus so that I can make better actions there. So in a nutshell, that is Linkerd, and we could dig into more of the content of it. But let's switch over to Istio. Any questions on Linkerd before I do? Ooh, now my Linkerd dashboard is really mad. I would definitely recommend the talk, going to the talk that happened last hour, because it was a great deep dive into Linkerd. If you have the chance to see that talk, that was really cool. Now, it might be interesting to pull up those stats from the dashboard, but I'm going to say Linkerd stat deploy, and I'm going to pull up the statistics that I saw in the dashboard, but here I'm doing it from the command line. So if you're more comfortable with the command line and getting the stats that way, this is a really, really powerful interface. OK, let's switch over to Istio. OK, switching kubectl over to Istio and switching Docker over to Istio. Now we've got our Istio cluster ready to go. Now I've done the install of Istio already. Kubectl get all dash dash. What is it? Get namespaces. Kubectl get all namespace Istio system. So similarly to Linkerd, it created its control plane and its own namespace, and it has all of the Istio content in place. Now, as you install Istio, similar type of mechanism, the Getting Started page is really elegant at getting you from just started to getting all the things downloaded to putting everything in place. Similarly, I already grabbed the Istio command line interface, and so that's ready to go. One of the things that you'll do as you install is pick a profile. And in this profile, these are kind of the default settings, the default things that are turned on and turned off. I've chose demo mode in this case, which gives me these features. But you could also choose a minimal install that actually disables mutual TLS if you chose to do that. Just get the logging and the monitoring, but not the security. That's totally fine. As I install it, like I did with Linkerd, I will turn on, not that one. I will turn on the namespace. So I'll come in here and I will label my namespace. In this case, I will label default. And say injection is enabled. Once I have that turned on, either in Linkerd or in Istio, all of the content that I provision from then on will have that Sidecar Proxy automatically injected. OK, so Istio has this great application that makes demoing this really, really cool. Now we're talking about north-south traffic, but this graph goes from left to right, so there is that. But then we start talking about east-west traffic, and it's also still going left to right, so there is that. But we start out with our traffic coming in to the ingress, and we'll put a proxy inside this ingress controller, much like we would put a proxy anywhere else. So as soon as the traffic comes in, now we'll do mutual TLS between all the other services. So here's another Sidecar Proxy inside this product page. It happens to be a Python app. The product page will reach out to product details and hit that Sidecar Proxy, grabbing the details there. The product page will also reach out to a reviews service. This is one of 3 Java apps. And the reviews service in version 1 shows no stars. In version 2, it shows black stars. And in version 3, it shows red stars. And so we'll use these 3 different versions of this microservice to see how we would kind of do a rolling update, or how we could shape that traffic in really interesting ways. In version 2 and version 3, to know how many stars it needs to get, it will reach out to the rating service. All of these brown boxes are the Sidecar Proxies. So we have north-south traffic coming into the ingress proxy. We have east-west traffic going between all of our containers. And so outside of each pod boundary, there is no traffic that is not secured with mutual TLS. OK, so let's fire up this app. Now I go here, and right now we see that there are no stars under the reviewer. We're using version 1. Now to accomplish this, we installed this. Monitor resolution is fun. We installed this virtual service. Now this virtual service very specifically says, please route all traffic to version 1 of this service. Now ideally we wouldn't have all 3 of them running at the same time, but I do have all 3 of them running just so that we can see the content go by. So we want to try out version 2 of this service, but let's only send a little bit of the traffic just to kind of get a feel for how this is going to work. So we'll still send 90% of the traffic to version 1, and we will send 10% of the traffic to version 2. (90-10). This is actually not 90-10, this is 80-20. That's cool. So we're going to send 20% of the traffic to version 2 and 80% of the traffic to version 1. So now as I refresh this page, we'll see that 4 times I will get no stars, and 1 time I will get black stars. Unless I'm really unlucky, and then I will never get black stars. There we go, there's black stars. So now we can get a feel for, is our service behaving? Is it doing what we want? Is the star data accurate? And once we've got that kind of solved, then we can upgrade and we can say, okay, I would like to go completely to version 2. So now we're not going to route any traffic to version 1, only to version 2. Let's apply that configuration. No downtime, and now I will always see the black stars. I put this virtual service in place of a regular Kubernetes service to get that additional routing configuration. Okay, so now we want to talk about upgrading to version 3. And I have a beta tester, his name is Jason, and the tester is going to go validate that version 3 works correctly. So I'm going to route all the things where we have a user named Jason to version 2 and everyone else to version 3, which in hindsight I think might be a little backwards. Let's send most people to version 3 and Jason to version 2. Okay. That's not right. Reviews Jason v2 v3. Reviews Jason. Fail. Nope, I'm going to crash out of that demo. Okay, so Jason was able to do that. The interesting thing, though, is if I sign in as Jason here, I'll get the other one, and if I don't, then I'll get the regular one. I think that's really cool. So crash out of that demo. So now we want to send about 50% of the traffic to version 3 and 50% of the traffic to version 2. So let's apply that rule. And now when I push the button, I'll get black ones and I'll get red ones, and that happens about half the time. Now it is random, so I may get black ones a bunch of times in a row. And once I've proven that that works, now let's flip completely over to version 3. And now we're all the way on the red ones. So we saw some interesting things. We could route traffic between 2 services. We could route it based on rules of headers or logins or other details. We could create a beta channel where users that have a certain header set or a part of an auth group go to the new version. And all of this is possible because we're standing in between those 2 services. Any questions on Istio? Yep. How does it map to a user? Good question. How does it map to the user? When I'm in here, book info, networking, let's go open up that one again. In this case, it's matching a header, and so it's pulling that data out of that header, but I could match it on other information. So this one, oh, that's exactly the same. It also matches on header details. Is the application looking at the header? Oh, is the application setting the header? Yes. So once I log in, I've got that cookie set, not that cookie. Yeah, I have that cookie set, and as I hit this product page and it makes the request off to the reviews page, it's setting the proper header so that the review service can understand which user is hitting that service. That was a great question. Thank you. What other questions do you have right here? Yep. Am I familiar with OpenShift? A bit. Mm-hmm.
Let me get you the mic. It sounds like it's getting complicated.
So now your mic.
Okay, so with OpenShift, you have the ability to do the rolling deployments that we just displayed there. How does Istio extend that, or why would you want Istio? Sorry, I have no idea.
Interesting. So why would I want Istio if OpenShift already kind of has this rolling deployment piece? Built into Kubernetes, we also have a rolling deployment where we can spin up new pods and start pushing traffic to it and then shut down the old pods. The difference is that I have portions of the traffic going to each one. So it isn't like, okay, we're done with version 1, everyone go to version 2, but rather I can have both of them happening at the same time, and I can grab a sliver of traffic and move it over at a time. And at the point where the new one is behaving, I'll move faster, and at the point where the new one isn't behaving, I'll move it back. I haven't terminated the old pods. I haven't made the choice to move all traffic to the new pods. Both of them are running at the same time.
Yep. Actually, OpenShift can also do that, but it's because it's using Istio under the hood.
Ah, so yeah, I'm comparing Istio to itself. That's awesome.
Yeah.
I learned something cool. It's kind of like, as long as you want to use Knative, you're already using Istio?
Yes.
Yeah, that was a great question. Thank you for clarifying, too. What other questions do you have right here? The next person has to ask the question from the back corner so that he can run. No, I'm just kidding.
Do you have a demo ready for Linkerd?
Do I have a demo ready for Linkerd?
He just did.
A demo application? I don't. But part of what makes Linkerd so powerful is that initial startup experience, and so that's really the Linkerd demo that I wanted to highlight. Okay, so while we're here looking at Istio, let's look at some dashboards. kubectl get svc -- namespace Istio system. Now there's a few, but I flipped one of them over to be, oh, I didn't, haha. Okay. Error upgrading connection. This may be a very short demo of demoing all the dashboards. Yes, we will totally fail to run all the dashboards, because these dashboards are totally awesome. Oh, here we go. So we have a Jaeger dashboard. If I look at this Jaeger diagram, this is how the traffic is actually flowing through my cluster. We start off coming into the product page, and then the product page will reach out to the Istio mixer. The product page will also reach out to the details, and the product page will reach out to the reviews. The reviews will reach out to the ratings. This is an actual dashboard of what's happening inside of my cluster. Not what the developer thought was happening, but what's actually happening, which is really cool. I'm going to break out of that. Let's look at the next dashboard. We missed the Grafana dashboards in Istio. Ooh, we're going to miss Kiali too. Bummer. The pod does not exist. Bummer, because it says that all of them are ready, but the dashboards don't. The cool part is that we get to see there is a Prometheus sync inside of Istio, and so we're able to see really great Grafana dashboards. There's also Kiali, which gives us kind of a great architecture around the things. Jaeger allows us to put in trace IDs and to be able to see a single request as it flows between all the services. And so all of these dashboards really work together in concert. The bummer part is you have to know where each dashboard is, because they're all kind of separate packages that Istio happens to install together. By comparison, Linkerd has a single dashboard that kind of puts them all in one place, meeting that similar methodology of Istio grabbing all of the industry standard components and bundling them together, and Linkerd focusing on building first-class components and really simple experiences. So there's kind of a difference in methodology there. So we got to see some really interesting things both in Linkerd and in Istio. And I like to make this analogy similar to crawl, walk, run. At the first level, at the crawl stage, a service mesh allows us to see the traffic in our cluster. So we'll get monitoring, we'll get logging, we'll get service health. I know what services are up, I know what services are down, I know how each service is performing, I'll get logs and metrics around that. As we get into the walk phase, here's kind of that step above that, where because I'm watching all the traffic, I can do really interesting intelligent routing, A/B testing between things, or rolling deployments where I don't push all of the traffic across. And then as we get to run, we can look at that traffic pattern and make intelligent decisions. We can build policies around it to say, hey, I just noticed a new dashboard is trying to connect to this database. Do I want to allow that? Or is this a rogue container that I should block? And we can make those intelligent decisions. We can have circuit breakers that turn things off, or we can spin up additional containers based on the analytics that we're getting out of our dashboard. The quote that I love from Zach Butcher, he wrote an Istio book, which is really amazing. He says, if it doesn't have a control plane, it ain't a service mesh. And so that's kind of that defining characteristic. We put a proxy sidecar on each container, and we have a control plane that allows us to communicate, to make intelligent decisions around our things. So you asked a question about what is the impact around this. Well, as we look at this, on the left is all the things that we had before. We have our Kubernetes control plane, we have our worker nodes, we have all of our pods, we have cAdvisor, we have kube proxy. That's all the things that we had in Kubernetes before. And what we added is all the things on the right. We have all of our service proxies, we have the control plane. The control plane is made up of multiple pieces, all of the sidecar proxies. So basically what we did here is we doubled the number of containers running in our cluster. Now the Envoy proxies are probably a little bit lighter weight than the Tomcat apps running inside the containers, but we're also doing a lot of TLS communication, and so maybe we're even doubling the amount of compute that we're doing in our cluster. This is a non-trivial impact if our only goal is to get that, yep, I checked the security box. You may not need a service mesh If what you're trying to optimize is less spend, just grabbing the stuff on the left is completely sufficient. But if you're after those features of controlling, securing, and observing, controlling, and securing the pieces of your cluster, then it's worth taking that additional barrier, that additional burden of this additional compute to empower those features. Observe, control, secure. Because we're able to see all of the traffic moving through our cluster, we can make really intelligent choices. Transparency of communication. We can see all of the traffic flowing there. We can log it. We can monitor it. Control. We can take additional steps. We can trip circuit breakers if a service is behaving incorrectly, or we could route between two different versions of a service. And secure. We have mutual TLS between all of the things. If these are features that you really need, a service mesh can definitely be helpful. And here's kind of my checklist. You might need a service mesh if you're running highly sensitive workloads, like PCI or PKI, if you have HIPAA things, if you must have security in all the things, both in north-south traffic and in east-west traffic, then a service mesh is perfect. Alternatively, if you're running untrusted workloads, such as multi-tenant workloads, then a service mesh can help you isolate the traffic between each other. An API gateway, by comparison, will only validate that the traffic coming into your cluster is okay. But once one tenant launches a poisoned pod, then it can reach out across namespace boundaries to all kinds of things without a service mesh. A service mesh is great for multi-tenant deployments to keep everyone in their lane. A service mesh is great when you need security in depth because you can't communicate between containers until the control plane approves it. If you need to do A/B routing or a beta channel or these more controlled rollouts, then that's a great use case for a service mesh. If you have one of these use cases, a service mesh like Istio or Linkerd can be a great choice. If you're only running first-party workloads and you only have a few services and you trust all of them, then you probably don't need a service mesh. And avoiding that additional compute cost can be really, really helpful. Any questions?
I actually have one.
Yeah.
So there's a fair amount of overhead associated with the service mesh in terms of extra sidecar containers and needing to manage the service mesh and everything else. How can you tell when you're at the tipping point of actually needing one? Because you have that list of items that a service mesh is good for, right? But if you only need one of those things, some of the time it's probably not worth installing one.
Agreed.
Any recommendations on how to tell when you're at the tipping point of when you really do need one?
Good question. When do I know that I'm at that tipping point of when I need it? I tend to refer back to this list. Am I running multi-tenant workloads or very secure workloads? That's usually the spot where I need it. If I'm trying to get really in-depth metrics around my containers, there's often better ways to get that than a service mesh. And so I'll probably not reach for a service mesh just to get metrics. But if I need those rolling updates or I want to run Knative, then running Istio can be really helpful. It is a fuzzy boundary, though, and so ultimately have that conversation with your organization and decide together that it's time to dive in.
Has anyone tried to do service mesh with more traditional tools rather than rewriting proxy, rewriting the sidecar things? No, I mean, we know for a long time how to do proxy and how to do canary or A/B testing using plenty of old school tools that work quite nicely in the containers and Kubernetes. Is there not an actor, another, I don't know, kind of solution saying, well, yeah, you can just use Nginx and this and that and plug it to Prometheus the same way and do reverse proxy the same way and do TLS the same way?
There's a couple of different ways to do that, and that's really elegant. You know, how could I do this without sidecar proxies? The first way is, I just don't. Yeah. Next up, I could implement all of these things as code in my application. And at that point, then I need to implement it in each service. So, you know, if I have a Java service, then I need to pull in the proxy code, and I need to remember to configure it. So in time, we kind of reach for the third way, which is I'm going to abstract that into a library. But now each microservice needs to remember to pull in that library. I'm still doing it all in the code. Part of the beauty of this fourth step of having it outside of the code is it's removed from the code. I can get Kubernetes to enforce the sidecar proxies in each piece. I don't need to build in retries or circuit breakers into all my code. I can leave that as an implementation detail for my cluster, for my service mesh, and my microservice can just focus on doing the task at hand. So there definitely are other options, but they're generally more developer intensive. That was a great question. Thank you.
If one were to decide to install Istio and Linkerd and go down that road, and the customer says that's too much workload, is there kind of an undo switch, like you undo that, or is this a one-way street?
Good call. So if I want to install Linkerd and Istio, am I now fully committed, or is there a backout mechanism? What's really cool is that we saw a little bit in Istio of routing traffic between two services where both of them kind of had the same name. But outside of that use case, pretty much I'm just connecting to that service by name. I just happen to have a service mesh proxying that traffic. So provided that I'm routing between services in the normal way, I just uninstall my service mesh, and I'm back to vanilla Kubernetes and doing all the things. One point of clarification, though, I probably don't want to install Istio and Linkerd. I probably want to pick one. Ultimately, you know, which one to choose, that'll be an interesting question, and we can argue about that one over beers.
With the initial uninstall, or the uninstall of Istio or Linkerd or whatever, would you have to redeploy all your pods because now they all have the sidecar?
Good call.
Or don't have the sidecar?
Yeah, if I was to uninstall my service mesh, all of the sidecars are still in the pods that were launched before then. So yes, I would need to then kick off my deployments to redeploy everything. I can do that in the normal, you know, rolling update way. I can just kind of walk through my pods, killing them off, and let my deployments recreate them. And because I don't have that piece inside Kubernetes that will automatically inject the sidecar, then the new ones just won't have the sidecar. In the meantime, what's really interesting, I've done this. Once you kill off the control plane, they're trying to check in to say, can I connect? And there is no control plane to approve it. So pretty much your cluster shuts down. So in general, I recommend doing that offline, where you have a little bit more control over, you know, taking down all the things without impacting customers. A gentler way to do that is we saw as we turned on that Istio namespace, we just told it to inject the sidecar proxies by labeling that namespace. We can unlabel the namespace and then tell all the deployments to kick off. Now they won't have the sidecar proxy. Now we can uninstall Linkerd, and then we won't get that same, you know, locked up, can't connect process. That's also a good way to test, you know, what if we didn't do this? Just turn off the namespace and redeploy everything and see if things speed up or slow down.
So do you and then you.
Oh, thank you. Is it possible to add services outside of Kubernetes to the service mesh?
Good question. Can I add services outside of Kubernetes to the service mesh? One of the things that do I have it? No, I don't. It's right here. Not here. One of the things that's really helpful in this diagram is we have that ingress proxy. We have that ingress controller that has a proxy. Similarly, we can have an egress proxy that is allowed to monitor the traffic leaving the cluster. And I may choose to have one egress proxy for all outside traffic, or I may choose to have like a shadow service, an egress proxy for each external API. And that can validate traffic as it leaves the cluster. Now on the upside, I can capture all the traffic that have the sidecar proxies enabled. But if I choose to disable a particular namespace, then yeah, that traffic is unrestricted, and it can flow out of the cluster unimpeded. So it's not a boundary, it's not a firewall, but it is a validation rule for all those things that the service mesh controls.
Is this stuff compatible with stateful sets?
Does Istio use stateful sets?
Oh, no, so let's say I have a stateful set. Is it compatible with all the pods that a stateful set would stand up?
Good question. Is it compatible with all the pods in a stateful set? I honestly don't know. Do you know? Yeah.
Yeah.
The answer is yes.
Oh, right, yeah.
So yes, it's compatible that you can get the MTLS, but you have to do your own service discovery if your stateful sets are individually addressable. Like if you have, you know, say Postgres, you have a master and a slave, you're going to have to handle the discovery so it knows which is master and which is slave.
Oh, good call. That totally makes sense.
Also, last I checked, Istio still doesn't do persistent TCP connections, which, I mean, a lot of the reasons you use stateful sets are databases, and transactional databases tend to want a persistent connection from the client, which last time I looked at this did not work with Istio. It was something you could actually do with old Linkerd. I don't know whether or not you can do it with new Linkerd. Yeah, okay.
Yeah, persistent connections. In theory, you're only securing the connection, and then once the connection exists, you just don't hang up. But yeah, I could see how timeouts could really break that. Good call.
Well, you know, let me, so everybody's
interesting. So Linkerd does automatic traffic detection, so it won't proxy. Yep.
So Linkerd will do automatic protocol detection. So for something like Postgres, it will recognize that that's not a protocol that it supports and will not proxy that traffic until we do support for MTLS for TCP.
That sounds perfect. Yeah. Once we've got TLS, mutual TLS for TCP, then we can do all kinds of magic things. I like that.
I got into this because when service meshes first came on the scene, I immediately had like database uses for them and was very disappointed to find out that I couldn't actually do any of those.
Right. Well, this has been a lot of fun. Thanks for letting me play.